In 2017, Google published a landmark research paper titled Attention is All You Need. That single paper introduced the transformer architecture, which is the foundation behind every modern large language model we use today. At their core, LLMs are essentially supercharged autocomplete machines. Their entire job is just to take in your tests and predict the next most likely word that will come after it over and over again. But to do that accurately, the model needs a deep understanding of context. This is where transformer and its secret sauce called self-attention comes in. Self-attention works on a simple truth. A word's meaning depends entirely on the words around it. Take for instance the word bank. On its own, this word is quite meaningless. But when you add a subsequent word to it like river bank or money bag, this tells you exactly what it means or what kind of bank we are actually talking about. So self attention allows every single word in a sentence to look at every other word simultaneously and measure how relevant they are to each other. And then it updates its meaning accordingly. To calculate this, the transformer converts every token into three vectors, which are called the query, the key, and the value. The query essentially is what correct word am I searching for, as the name says, query. While the key means what each word advertises about itself. Take for example the word mother. What does it say about itself? If you think as a human, you know it says family, relationship, blood. And the last one, which is called value. This is the actual contextual information the word holds. For example, the word mother. What does it hold? Family, relationship, blood. Now the math happens in three straightforward steps. We calculate the math scores. The model compares the word's query vector against the key. So it compares the word query vectors against the key vectors for all words to produce the raw similarity scores. The second thing it does, it converts to percentage. It scales those scores down and passes them through a softmax function. This turns the raw words into clean percentage weights and sums them to something like 1% or 100%. Then the third thing it does is blend the context. Now the model multiplies those percentage weights by each other's words value, by each other words value vectors and sums them up. The result is then a new context-rich vector for that word. The paper takes the concept further with the multi-head attention. Instead of running this calculation just once, why don't we split the QK and value into multiple subvectors and then run them in parallel across each head. So one head might focus on grammatical connection, the other head might focus on something that is not grammatical connection like relationship. Is this word talking about life? Is this word talking about a living object? And so on and so forth. So finally, the output of each head are combined together, giving the transformer a complete multi-layered understanding of the text. This rich contextual map is precisely what elevate the basic autocomplete engine into our large language model.